And we're back with another exciting Leetcode problem. Today we've got Leetcode 2181, merge nodes between zeros. So basically what they want us to do in this problem is you're given a linked list of values that are surrounded by zeros. The values surrounded by zeros need to be summed. So 3 plus 1 equals 4. Likewise, in the red here, we have 4 plus 5 plus 2 equals 11. You need to return a new linked list with those values. So you can see we've got a linked list here of 4 and 11, and that is our output. So the first thing we want to do actually is create a dummy node for our new linked list, which is just going to store those sums. So I'm going to say let dummy equal new list node. Initially, I'm going to set the value of this dummy node to anything because it really doesn't matter. It's just a placeholder at this current point in time. So I'm going to say 9,999. I'm going to set its next pointer to just null. From here, we need to traverse our linked list. So let's make a variable called cur, and I'll set it to head initially, and then I'll say while cur. Basically, if cur is truthy and actually exists, we want to traverse through our linked list by using cur equals cur.next. And from here, I'm going to console.log the value of cur. Let's see what this returns. We've successfully traversed our linked list. Okay, so this looks good. Now we need to check, are we currently on a 0 or a non-zero value? If we're on a non-zero value, we know we need to add it to some type of sum. Okay, so let's make a variable called sum and set it to 0. And also in cur, we could say if cur.value does not equal a 0, we know we need to add it to our sum. So that's going to get us to add all these values, right? But what happens when we hit a 0? So when we hit a 0, we need to dump that sum into our dummy list. So we'll say else. So if we hit that 0, we need to dump it into our dummy list. So I'm going to make a new node to attach to the dummy list. I'll say new, I'll just call it node actually, new list node. And I'm going to pass in our sum, and it's also going to have a null next pointer. Okay, and actually we're starting on 0, but that's kind of redundant. We don't really need to start on 0 because we can actually just go ahead and start straight on a non-zero value, right? So I'm going to say cur is actually going to be head.next. So just so we skip that first 0, okay? So now we're creating this new list node, and now I need to attach it to dummy. Something like this, dummy.next equals node. And then we also need to now progress the dummy node. So I'll say dummy equals dummy.next. But this is actually problematic, even though it looks good on the surface. Let's console.log the dummy list so I can show you what I mean. And you can see we're actually not even looping through the list because I needed to do cur equals cur.next. Okay, so why is it returning 15? Well, firstly, we're not reducing the sum back to 0, so I need to do that. Let's reduce the sum back to 0, run it again. Okay, so now we're missing the 4, right? So initially we have 999. We wanted to set the next pointer to 4, and we want the value after that to be 11. But right now when I console.log dummy, I'm just getting 11. We've lost these two values. So what's happening? As we traverse the dummy list, we are losing the pointer that points to these nodes. In other words, we need to create another pointer so not to modify dummy, so then we can return the dummy list. and not lose access to these nodes. So I'm going to make a variable called tail, and I'm going to set it to just dummy at the start. And instead of using dummy.next, I'm going to say tail.next, and tail equals tail.next. Now the tail is going to be the one traversing the dummy list, but when I return dummy, it's going to give me what I want. So let's do this. And you can see we're now outputting what we want, and we don't need this initial value in our answer, so we can just return dummy.next and submit. And there you have it. There's our answer. So big takeaway here is you're allowed to create a dummy node and a dummy list to store your sums. That's still a space complexity of constant time O of 1. This is because it doesn't matter how big your linked list is. At the end of the day, you're just creating a new dummy list with one node initially. So that's why it's constant time for space complexity. And then time complexity is linear time, or O of n. This is because you're still going to make a dummy list that is proportional to the inputs, right? Okay, so I hope you guys enjoyed this video. Be sure to like and subscribe, and I will see you in the next one.